start the question. So this is like your next theorem. So here you can see this. There are two quadrilaterals. One is external quadrilateral ABCD, and there is another quadrilateral internal one, that is APCQ. You can clearly see by the quadrilateral with the there is inside there is one quadrilateral, and this external quadrilateral is always already parallelogram, that has been already declared. It's a parallelogram. So what our duty is to prove this internal quadrilateral APCQ is also parallelogram, that we are supposed to do. So now that means if you are able to prove PC equals to AQ, one pair of opposite side equal, and again if you are able to prove AP equals to QC, if you are able to prove opposite sides are equal, then we can say this will be also can be declared as parallelogram, which we have to do. Okay, so remember this external one is already parallelogram, internal one is not parallelogram, and one more thing given is this DP equals to QB. Okay, so now for your easiness, I'm going to set this two triangle here, so that you can feel the focus here. So why I have drawn this set shadow here is because in this question we are going to prove these two triangle congruent. Now I'll ask you why we have to prove this two triangle congruent, because our target is to prove this parallelogram. The reason is, if we are able to prove this two-sided triangle congruent, then we can say this side and this side will be equal, because they will be the corresponding sides of congruent triangle. Yes, and opposite, and if from the triangle's viewpoint we can say they are equal, and same thing if you see from the viewpoints of this quadrilateral, opposite side will be equal. And again we will prove another this white triangle also congruent in the same way, and again these two sides will be equal. So in this way opposite pair of opposite sides will be equal, and we can say they are parallelogram. Okay, so just let me begin. For that I have to. Okay, so first let me mention the name of the triangle. The first triangle is the upper one, DPC. In triangle DPC, and the down one sided triangle is in triangle AQB, number one. So I will let you know first from which axiom they can be proved as equal. Okay, I have already said it is side angle side. So why side angle side? I'll tell you. See, this DC and AB are actually equal because they are the opposite sides of this parallelogram. Yes, and again this angle. Okay, I'm marking here. This angle and this angle will be equal. So why they will be equal? Side angle. Okay, because you can see this is alternate angle, and because they are lying inside the parallelogram. And the last one is DP equals to QB. This facility is given by the question only, so no need to worry. So it is side angle side. Okay, so quickly you can copy this. So DC is equals to AB. This is one given, not given, opposite sides of parallelogram. And number two is angle D is equals to angle B. Angle D equals to angle B. Yes, and the reason is alternate. And number three is this DP equals to BQ. DP equals to BQ. This is given because that symbol only has been given by. After doing these three things, we can write triangle DPC is congruent to triangle AQB, and this is from SAS axioms. You can write SAS axiom, and then after that you can write finally PC equals to AQ, because now they become corresponding sides of congruent triangle. Corresponding sides of congruent. This is the symbol of congruent, and this is the triangle. Okay, one pair of opposite sides are proved. Now we have to prove this pair also opposite. For that we have to prove this also congruent, and obviously the same method, opposite side alternate, and DP equals to BQ. But if you have done the same thing here, then you don't need to do full process. You just simply, you have one facility, you can write triangle, another triangle DAP is also congruent to triangle BQC. Same, you can write same for same as 1. So why same as 1 means, so this will be also proved same as 1. It means if these two become congruent, so this, then this PA equals to also QC. So PA equals to QC, fifth number. So this is also corresponding sides of congruent triangle. And in number 6 statement, you can write means AQ APCQ. Okay, I'm writing APCQ is parallelogram. Why? The reason is as being their opposite sides are equal. Okay, if anything's opposite sides are equal, they are always parallel. Being their opposite sides are equal. So in this way, this is done. Okay, so here I want to make you note one thing. So you can see here, this actually this second pair of triangle, we have not done all the process because this is the process for this one is similar. So if you have done already same process before in the same figure, then for the second one you have one facility that you can simply write, you can directly write congruent, and you have to write the reason as this is also in the, we have done this is also in the same way. Consider with from the first pair of triangles, second triangle also can be done, but make sure that the process should be same. Okay, so that is the thing you need to understand.